Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I hope you are doing well. This is the second lecture on hybridization. In this lecture, we will discuss about sp2, sp3 hybridization. So, let us start from this topic. First is sp3 hybridization. sp3 hybridization. The hybridization process in which one s orbital and 3 p orbitals are intermixed together to produce 4 number of sp3 hybrid orbitals is called sp3 hybridization. So, try to understand the definition. sp3 hybridization, where one s orbital and 3 p orbitals will participate. So, let us draw the diagram. Here one s orbital, and you know that s orbital is round shape. So, this is s orbital. Now, we will draw the p orbitals. Three p orbitals. sp3 hybridization. P orbitals. Here it is px, py and pz orbital. So, we will get 4 number of sp3 hybrid orbitals. 1, 2, 3 and 4, and every orbital will be known as sp3 hybrid orbital. So, dear student, try to understand, one s orbital and 3 p orbital will intermix together and they will produce 4 number of sp3 hybrid orbitals through the process sp3 hybridization. Now, we will get the next explanation with example. Example. This is it was the basic diagram. Now, we will get example. Very common example, stage 4. You know, electronic configuration of carbon is at excited state 1s2, 2s1, 2px1, 2py1, 2pz1, and the structure is this, having single bond. And you know that when carbon-carbon single bond, then all the single covalent bonds are sigma bond. When carbon-carbon double bond, all the double bonds has 1 sigma and 1 pi. When triple bond, then 1 sigma and 2 pi. So, these are the bonds between the carbon-carbon atoms or different covalent bonds. So, if here 4 number of sigma bonds, then how can we find out the hybridization type in this molecule? Now let us go for the formula, that is steric number equal to number of sigma bonds plus number of lone pair electrons. So in this carbon atom, how many single bonds are present? 4, and there is no lone pair electrons, that is 0. So 4 value will indicate sp3 hybridization. Now the next formula, the value of H or Z equal to half into V plus X minus C plus A. Here valency electron, valency electron of carbon is 4, so it is 4 plus number of monovalent atom is 4, 1, 2, 3, 4. So you can write here also 4 minus 0 plus 0. So it is what? 8 by 2, that is 4. 4 indicates what? sp3. So from these two formula we can say that the type of hybridization of carbon in this molecule is sp3. Now we will draw the next diagram. Okay. Okay, now our next diagram. Here in this carbon atom, we can observe that 1 s orbital and 3 number of p orbitals are present. So, round shape to s1 and 3 p orbitals. 1, 2, 3. So here 3 p orbitals, 1, 1 and 1. Total electron is 3. Okay, 3. So this is 2px1, 2py1, 2pz1. 3 number of p orbitals will intermix together, sp3 hybridization, and they will produce 4 number of sp3 hybrid orbitals in the valence shell of carbon. 1, 2, 3, 4. This is what sp3 hybridization, hybrid orbital, sp3 hybrid orbital. Now this carbon is ready for making bond with the another atom like hydrogen, chlorine, etc. Now bond formation. Bond formation. Bond formation. Bond formation. Bond formation. So this carbon atom having 1, 2, 3 and 4 having a single electron. So here head to head overlapping, head to head overlapping, head to head overlapping and head to head overlapping. This is the structure of your CH4, and bonding angle is 109.5 degree. So it is the standard bond angle of sp3 hybridization. So in the CH4 molecule, bond angle is 109.5 degree, and in this molecule there is no lone pair, so standard bond angle will remain present, and sometimes the bond angle will be changed due to the presence of lone pair electron. So we will discuss it later in the next videos, is when and at what condition your bond angle will be changed. So this is the structure of your CH4. Now another example. Another example, NH3, nitrogen is bonded with 3 number of hydrogen like this. So here the steric number equal to number of sigma bond plus number of lone pair electron. So in this structure we can observe that there are 3 number of single bonds. So 3 sigma and 1 pair electrons are present as lone pairs. So how many pairs? Actually here this is the pair number. So here 1 pair, so it is 1, and total is 4, that is sp3. Now try to understand the electronic configuration of nitrogen. 1s2, 2s2, 2px1, 2py1 and 2pz1. So here in the valency shell there are total number electron or valence electron is 5. So the formula H equal to half V plus X minus C plus A. So valence electron is 5 and number of monovalent atom is 3, 1, 2, 3, minus 0 plus 0. So total will be 8 by 2, that is 4, 4 is what? sp3. So in this NH3 molecule also the hybridization process is sp3. Now look at the diagram, my dear students. Nitrogen 2s2, 2 electrons. Now the 3 number of p orbitals, number of p orbitals, number of p orbitals, 1, 2 and 3, 1, 2 and 3. So 1, 1 and 1, 2px1, 2py1, 2pz1. So sp3 hybridization process, and here we will get 1, 2, 3 and 4 number of hybrid orbitals. So this is the nucleus of nitrogen. So this N is used for indicating the nucleus of nitrogen, and this is the sp3 hybrid orbitals. sp3 hybrid orbital. So dear student, here electronic distribution will be here paired, and here 1 and here 1 and here also 1. So look at the diagram again. Here 2 electrons and here single electron. So these electrons will be distributed similarly among the hybrid orbitals. So it will be present in one orbital as a pair, and the rest of the orbitals will contain the 1, 1 and 1, because here 3 electrons are present in the unpaired condition and these 2 electrons are present as a paired condition. So this condition will be present among these hybrid orbitals. So here 2 and here 3. Okay. Now these unpaired electrons will participate in covalent bond forming, that is sigma bonding. Okay. Here we can also show this hybridization, that is sp3 hybridization. So it will be 1s2, Psi1, Psi2, Psi3 and Psi4. And already I have said about this Psi sign, SiGH, that is for hybrid orbitals. So here 4 number of hybrid orbitals. So it will be sp3 hybrid orbitals, and electronic distribution will be 2, 1, 1 and 1. Now Bond formation. Bond formation. So bond formation 1, 2, 3 and 4. So you know that nitrogen, here one orbital has 2 electrons as a lone pair and 3 as what? Unpaired. And these 3 unpaired electrons will be paired with the 3 number of hydrogen atoms through the head-to-head overlapping like this to form the sigma bond like this. And here the standard bond angle 109.5 degree is not present. Why? Because this lone pair electron, because this lone pair electron repel this bond pair electron. As a result, the bond angle become changed into 107 degree. 107 degree. So in NH3 molecule, hybridization is sp3, but their bond angle is not 109.5 degree because of the presence of lone pair electron in the hybrid orbitals. In the next video, we also discuss details with the different molecules having the different bond angles. Just in this molecule, we have described the process of hybridization and their bond angle. But detailed discussion will be given with different molecules in the upcoming videos. Okay. So this is the hybridization of NH3 molecule. Okay. Now, look at the board, everyone. NH4 plus. Just before NH4 plus, we have done the NH3 as what? sp3 hybridization. So what hybridization is present in the NH4 plus ion? Look at the board, everyone. You know NH4 plus structure is this, like this. Here lone pair electron is shifted to H plus, and this is what? Coordinate bond. Coordinate bond. What is coordinate bond? Just I am telling you the definition in short. When a pair of electron is supplied by an atom to the another atom, and the other atom will not contribute any electron but participate in sharing that bond is known as coordinate bond. When a pair of electron is supplied by an atom to the another atom, and the other atom will not contribute any electron but participate in sharing, that bond is known as what? Coordinate bond. It is another name is what? Dative bond. Dative bond. Usually we see that in covalent bond, 2 unpaired electrons from 2 different non-metallic atoms comes together and they will be paired. But in coordinate bond, pair of electrons come from 1 atom. Actually, the coordinate bond is the covalent bond, one type of covalent bond, but this bond is for lone pair electron. So coordinate bond is especially for what? Lone pair electrons. Okay. Now look at the example. In H3, you know, the lone pair electron is present in nitrogen atom. When a H plus comes closer to this NH3 molecule, then what will happen? This nitrogen will provide the lone pair electron towards this H plus, and this is the coordinate bond. It is symbolized by the arrow sign, and this arrow will pointing from donor to receiver atom, and the other atom must have the capacity to share that supplied lone pair electrons. That means it must have the empty orbital. Again, it must have the empty orbital that will participate in sharing. It means here H plus means it has no electron and its 1s orbital is empty. For that reason, the lone pair electron supplied by this nitrogen is used sharing between this nitrogen and H plus, and they will form what? NH4 plus. So this is the donor atom or supplier atom, this is the receiver atom for this lone pair electron, and this is the symbolization arrow sign for coordinate bond. Now dear student, we will shift to the now hybridization process. So look at the formula. Steric number, number of sigma bond plus number of what? Lone pair electron. Here 1, 2 and 3 sigma bonds are present, you can observe, and one is what? Coordinate. And very interesting information and very important information, that is coordinate bond act as a sigma bond. Again, coordinate bond act as a single sigma bond. So this coordinate bond will be counted here as what? Sigma bond. So when we count the hybridization process or calculate or determine the hybridization process, in that case we will consider the coordinate bond as a single covalent bond, that is sigma bond. So 1, 2, 3, 4 sigma bond 4, and here lone pair is 0, that is 4 means sp3, and the next formula H equal to half into V plus X minus C plus A. The valency electron of nitrogen is 5, you know it. So it is 5, 1s2, 2s2, 2px1, 2py1, 2pz1. So this is the 5 number of electrons in nitrogen atom. And here 1, 2, 3, 4. Number of monovalent atom is what? 4 minus C. C means what? Charge on cation, and this is the cation, this is the NH4 plus, so here charge is 1. So this is 1, this is not the anion, so value of anion is 0. So 5 plus 4, 9, and minus 1, that is 8. 8 by 2, that is what? Again 4. 4 means what? sp3. So dear student, try to understand here the hybridization process in NH4 plus is also sp3. Using this formula, steric number, and the value calculation of H is same. Okay. Now draw the diagram. Okay. sp3 in nitrogen atom, right? Nitrogen atom. So here 1s and 3p are present. So sp3 hybridization will make what? 4 number of sp3 hybrid orbitals, psi1, psi2, psi3 and psi4, 2, 1, 1 and 1. These are the what? sp3 hybrid orbital. Now draw the diagram. 2s2 2px1, 2py1 and 2pz1. To px1, to py1, to pz1. sp3 hybridization. So 1, 2, 3, 4. So nitrogen here lone pair, single, single and single. Now dear student, this is the sp3 hybridization. Now what will be the bond formation? Okay. Now bond formation. Now bond formation. Bond formation. Look at here, bond formation. Nitrogen, this is the lone pair. 1, 2, 3 and what? 4. And 1 will contain lone pair and the rest of the 3 will contain what? Single or unpaired. Now this unpaired becomes paired through the covalent bond, head to head overlapping sigma and also here sigma, but this lone pair will participate in coordinate bond formation with H plus. With what? H plus. So here the standard bond angle will remain. Why? Because in NH4 plus there is no lone pair. In NH4 plus there is no lone pair electron remain after the bond formation. But in NH3 you know that one lone pair is present. So in NH3 one lone pair is present, that means one pair electron is present as lone pair. But in NH4 plus this lone pair is used up to make coordinate bond with NH4 plus, and we know that this coordinate bond acts as what? Single covalent bond, that is sigma bond. So very simple, here sigma bond is present for. In other language or in other way. So you know that CH4 there is no lone pair and there is a bond angle is what? Standard bond angle is what? 109.5 degree. Why? Because there is no lone pair and sp3 hybrid orbitals will maintain the standard bond angle 109.5 degree in CH4. Similarly, here the standard bond angle will be maintained in NH4 plus ion because here lone pair electron is no more present after the bond formation. So the bond angle is what? 109.5 degree. Dear student, I hope you will understand this. So NH3 is 107, NH4 is 109.5 and CH4 is also 109.5 degree. Okay. Now these are the example of sp3. Now we will move to the sp2. sp2. What is the name of this molecule? You know, ethene. Ethene molecule. Here carbon-carbon double bond is present. Another thing is that when carbon-carbon single bond, this is another technique, then it is what? sp3. When carbon-carbon double bond, that is what? sp2. And when carbon-carbon triple bond, that is what? sp. Dear student, try to remember this. When you will see that carbon-carbon single bond, that is sp3. When you will see the carbon-carbon double bond, that is what? sp2. When you see the carbon-carbon triple bond, that is what? sp. Okay. Now we will try to solve that. Steric number. steric number is number of sigma bond. So in this carbon, how many sigma? 1 sigma, 1 sigma, 1 sigma. That is 3 sigma. How many sigma bonds here? 3 sigma bonds here present. Okay? You have 3 sigma bonds are present. So here steric number of this carbon atom can be calculated. You know that here number of sigma is 1, 2 and here 1, 3. So 3 sigma bond plus lone pair is 0. Because in the electronic configuration of carbon you can observe that 1:2, 2s1, 2px1, 2py1, 2p what? Z1. So 3 is what? sp2. And the next formula is what? H equal to half V plus X minus C plus A. Half. Valence electron is what? 4. And here the number of monovalent atoms are 2 minus 0 plus 0, that is what? 6 by 2, that is 3. 3 means what? sp2. sp2. Okay. Now, what will be the diagram? What will be the diagram? Two S1, then 2px, 2py and 2pz. 2px1, 2py1, 2pz1. sp2. sp2. It means here 3 number of p orbitals are present, but from this 3 p orbital, 2 number of p orbital will be intermixed and 1 remain pure. So, what will be the diagram? Again, from these 3, 2 will participate in the intermixing process or hybridization process, but 1 orbital remain non-hybrid. So, 2p, px and py will be intermixed together with the 2s orbital and they will produce 3 number of hybrid orbital. 3 number of what? Hybrid orbital. So, in the carbon atom 3 number of hybrid orbitals will be present and the 2pz orbital, that will remain what? Non-hybrid. So, they will contain the electron, but their name will be, this is sp2 hybrid, but this is what? Non-hybrid orbital. Non-hybrid orbital. So, again, in this carbon atom, 1s, that means 2s1 and 2px1 and 2py1 will be intermixed together, but 2pz will remain what? Non-hybrid, that is non-hybrid orbital or pure atomic orbital. Okay. Now, this is present in the valence shell of carbon atom. That carbon atom is present in this structure C2H4 or ethene molecule. Okay. Now, draw the bond formation. Okay. Bond formation. Bond formation. Bond formation. So, 1, 2, 3. 1, 2, 3. This carbon having these 3 sp2 hybrid orbitals and 1 is non-hybrid. The non-hybrid is marked in this blue color. Look at here. I am marking the non-hybrid as a blue color shade, and here also a non-hybrid will be present like this, and here 3 orbitals will be present as sp2, 1, 1, 1, and here head to head overlapping, so like this, and here one unpaired, And in this diagram, you can also observe that the pi bond, dear student, pi bond. So this unpaired will be paired with the hydrogen through the head-to-head overlapping, sigma bond, and here sigma bond, and here another sigma bond. But this pi electron which are present perpendicularly to each other will must participate in sidewise overlapping, that is what pi bond. So in this diagram we can easily say that this is sigma bond, this is what pi bond, these are the sigma bond, and the orbitals which remain non-hybrid or pure atomic condition, pure atomic orbitals, they will participate in pi bonding. Again, the orbitals which are not hybrid will participate in pi bonding in the hybridization process. Okay. Now this is the structure of your ethene molecule, and what will be the bond angle? Here the bond angle is what? 120 degree. 120 degree, right? 120 degree. This is what? 120 degree. Okay. So we'll draw the next example. sp hybridization. sp hybridization. 1, 2, 3 and then 4. For example, this molecule, this is what? Butane 2 or 2-butane, butane 2. So here carbon-carbon single bond, but in this carbon triple bond, in this carbon single bond. So very simple, we can say that this carbon sp3 carbon, this is what? sp carbon, this is sp carbon, this is what? sp3 carbon. Now in the triple bond we will find out the hybridization type. Steric number, you know that steric number is number of sigma bond. Here sigma bond is 1 and here is 1. Again here is 1 sigma, here is another sigma. So 2 sigma plus 0 lone pair is 2. 2 means what? sp. Now the formula H half into V plus X minus C plus A. So valency electron for this carbon is what? You know, 4, and number of monovalent atom is 0, minus 0 plus 0, that is again 2. 2 means what? Is P. So very simple, we can say that the number of sigma bond here is 2, so sp hybridization, and here the value of H is 2, so sp hybridization. So in this structure where carbon-carbon triple bond is present, that is sp, and where single bond, that is what? sp3. Now what will be the diagram for sp hybridization? Okay, carbon, you know, 1 is 2, 2 is 1, 2px1, 2py1, 2p what? z1. sp hybridization, and they will remain what? Pure atomic orbital or non-hybrid orbitals. Non-hybrid orbital, they will be present. So after hybridization it will be 1 is 2 and psi 1 and psi 2, that is what? sp hybrid orbital, sp hybrid, and this will what? Remain 2py1 and 2pz1 will remain what? Non-hybrid orbital. Okay. Now we have to draw the diagram of this sp hybridization. Again here 2s1 and 3 p orbitals, 1, 2 and what? 3. 1, 2 and what? 3. sp hybridization. You know that 2px1, 2py1, 2pz1, 3 orbitals are present, but 1 p orbital will be intermixed together. So the name will be what? Sp hybridization. So we will produce 2 sp hybrid orbitals and remaining 2 orbitals as non-hybrid. 2 orbitals will remain as what? Non-hybrid. There is red marked here. There is red marked here, and unpaired, and this is the what? Non-hybrid orbital. Non-hybrid orbital. And this is what? Sp hybrid orbital. Hybrid orbital. So non-hybrid will make the pi bond and hybrid will make the sigma bond. Now the diagram or bond formation. Bond formation, right? Bond formation. So this carbon is sp3 because single bonded, but this is what sp. So what will be the diagram? sp3 means 4 number of 1, 2, 3 and 4. 4 number of hybrid orbital. This is carbon 1, 2, 3 and 4. Now this carbon is what? sp. So it will be 2 sp hybrid orbitals, 1 and then 2. Will draw from more left side because it needs more space. Bond formation. So this will what? 4. Again 1, 2, 3 and 4. So this carbon having 4 number of sp3 hybrid orbitals, and 3 will be head to head overlapped with 4 number of hydrogen like this, and here one will be paired with sp hybrid orbital. This is the second carbon, that means this carbon, and having the non-hybrid orbitals also 2, and non-hybrid orbitals are here presented in this way, having unpaired electron. Having what? Unpaired electron. So this is carbon, this is carbon having unpaired, this is the shade for what? Non-hybrid orbital. Okay, this is the second carbon. Now this is the third carbon is similar. Third carbon is similar. sp hybridization and having 2 non-hybrid, and the last one is what? sp3 hybrid. Okay, this. Like this, head to head overlap. Okay. Now this non-hybrid like this. Now these non-hybrid orbitals will do sidewise overlapping. For example, if it is py, so it is py, it is pz, it is pz. Okay. So py will overlap with the another py of another carbon, and pz will overlap with this another pz orbital. So here is pi bond and here is another pi bond. So all single bonds here are sigma and rest of the bonds are what? Pi bond. So very simple, we can say that when triple bond is present, that is sp hybridization. When single bond is present, that is what? sp2. When single bond, this is sp3, but when double bond, that is what? sp2. Okay. So my dear student, in this video we have discussed with some example of sp, sp2 and sp3. Inshallah, in the next video on this hybridization topic, we will discuss about this hybridization process, but with more examples. So this is the part 2, lecture 2, and in the part 3 we will discuss about the more on sp3, sp2 and sp hybridizations. So Allah Hafiz, Assalamu alaikum.